I want to draw a bar here at the bottom with some information, right? Basically, so I can start, so I show some information to the user, even if nobody's going to use this, but you know what I mean. But also, so I have a place to put debug information, because for example, like if I want to print something here, you know, I don't know, let's imagine that we want to print, I don't know, something, right? To debug it, because we're going to have to debug some stuff. You see, that's kind of what happens. It's cool, but it's not what we want, right? So instead, it's better to basically draw like a bottom bar, which I think that's what I'm gonna do. So for the bottom bar, we are gonna so let's say bottom, let's call it like this, and it's gonna be a string. So first, there is gonna be some information, and yeah, let me make it a variable. So first is gonna be some information that says q to quit, and then eventually I'm gonna say c or e, like, well, let's leave that for now. But let's focus on quitting, because I'm basically control Cing every time to kill the process, and I don't want to do that. I actually want to properly quit, because otherwise this is probably not running, right? So that's it's no good. So now we just draw basically the bottom bar, okay? But where do we draw it? So for that, we actually need to read, let's say here, read the environment. So we are gonna have like a width, and I think there is, let me see. So let's see, columns. Okay, it's exposed. So there is this variable, columns and lines. So these are the two variables that we're gonna use, and they are, I think they are updated automatically. So this is basically our window size, okay? Which means that for the height, we can actually draw this at height, and I'm pretty sure it will have to be -1, because if you think about what this represents, it's kind of like the number of lines that you have, so it's always like starting by 0. So yeah, we need to do that, and then I'm gonna draw it at 0. So there you go. So let's see how this looks. Okay, yeah, see, that's what I wanted. So here at the bottom we have this, and if we resize this, in theory, yes, you see, it keeps even this. So that's cool. This means that these variables are updated every time the size changes of the terminal, which, because we're basically in a room loop here, it basically gets picked up automatically. Cool. Now we're gonna be using this to show also some debug information. So we're gonna use if debug, so this doesn't show up to the users, and I'm just gonna do a bottom bar. We're gonna append another string. We're gonna put a tab, maybe a couple of tabs, I don't know. Like, I mean, I could draw separate things, but you know, it's nice, but you know, if I just put it on, I want it on the same line, so I'm just gonna put it on the same string and hope that it doesn't go too far, basically. I don't want to do layout math yet. So what I want to put, so I want to put the width is width, and the height is height. Okay, so that should be there. And we still need to kill this, we still haven't implemented that. Okay, width and height, so it's like 85 to and now it's, yeah, okay. Yeah, so you can see how the number changes dynamically, which is cool. And I wanted to do this because I want to, so let's do the quitting now. So basically rendering here, let's say, so this is like the render pass, and And here we need like to handle input. Yeah, which is interesting because if you think when you are making kind of like a game loop, you usually put the update first, and before the update you handle the input, right? So the frame where the user presses something, that event, like when you move the mouse or you press a key on the keyboard, that event gets processed on that frame, and the effects of that change are rendered instantly on that frame, because you do freeze handle events or handle inputs, then update your state, and then you render, right? But here we do it the other way around. We freeze render, and then we handle the input. So it means that everything goes with one frame of lag, in a sense, right? And why we do that? Because the input here, it's blocking, basically. So it's not like in a game loop, where you just check a piece of state saying, is the button pressed? Because some event set that state, like with an interrupt handler or something. Here we are literally just gonna read from the terminal, and that's a blocking thing. Like we are used to it. Like if you do a normal program and you do like anything in Swift, you can do read line, for example. That's basically a blocking thing. So we're gonna do the same thing, but instead of using read line, I'm gonna use a function that comes with ncurses, which, if I'm not mistaken, it's called get char. This one. Right, and we can say this is the input, right? So if I do this, if I kill this, I mean, you're gonna see. Well, I guess you will see something, right? So if you do this, so now in theory the program is stopped here, and if I move, oh, that still works. Make a decision of that. So for now, let's just go with this, and we can actually try it, right? So now, why do I want this bar here? Because I want to say last input character. Let's do this, and here I want to say last input character input. I'm just gonna do this, basically. I'm just gonna convert it to a string, right? And I want to put this here. So now if I run, I need to kill it again. Basically, if I press this, I see the integer representation of every key on the keyboard, which I will need that because all of this works with basically the ASCII table. But sometimes I'm not sure how to get some of that stuff, for example a tab, so I may need to play with the numbers directly, which makes it not very convenient, but it actually works. So let's get the input, let's switch on that, and let's say, so for example, if it's a Q, it's 113. So let's say quit to true, and yeah, it's the default, and for the default we just break. Okay. So let's kill it for now, but now if I press Q, yeah. And this properly resets the terminal because we are doing this entry. So step by step, we're getting there. So now we have the freeze, basically full control of input, and we can actually start, growing from here. Now, even though I just did this, I feel like it's kind of like a pain in the ass to toy with the numbers. But ideally you will want to do this, but I'm not sure if I want to do that. Maybe I can just use the ASCII, because Swift has basically, if I do character in I2Q there is an ASCII value here, but I need to convert it to int32. Right, so this needs to be an int32, and I need to force unwrap this. And in theory, that should all be the same. Yes. So that's a way of doing it. Maybe we can make some... Maybe I can do this. So if I can do string, and I can say ASCII 32, you know, and we can just put all of this. And yeah, it's not super safe. Yes, I need to do this. It's not super safe, of course, because you can you can put any string here and try to ask for the ASCII value, and it's not gonna work because it needs to be just one character. But you know what I mean, right? It works. It works. So I can do this. Cool. So now with this done, and I'm probably just gonna put this in another file because it's gonna start getting, like, I don't mind having, you know, things on the same file. I'm actually pretty much always having everything on the same file for this kind of stuff. But you know, it's gonna start getting complicated, and I want to try to keep it to a minimum. Okay, so we can quit. That's cool. What's the next step? I think the next step will be to like draw this first and second task and basically switch between them and basically somehow highlight them, right? Because for that we need to introduce another concept from ncurses, which is the attribute system. You can have, basically it's like the way the colors are done. You can enable attributes, print a string into the console, and then disable the attributes. And those attributes can be colors or underlines, bolds, and there is a bunch of them. And if I'm not mistaken, that it doesn't really work with Swift, because like if you look at here, imagine, like if you look for attribute, let's say, attributes. See? So this usually means that here there is a bunch of things, but we are looking at the Swift representation and it's empty. You see, like, I mean, there should be a lot of things here and there is nothing. So that means that Swift is missing stuff. So let me move this here. And if I look at the same thing here, yes, exactly. See, so this is the original header file in C, and you can see we have like this, a bunch of attributes. And it doesn't work because it's a macro that uses another macro, and this macro, like, it's a bit complicated and stuff like that, and Swift basically freaks out. The way this will work is the following. I want to this bar, for example. Let's start with the bar and then we go back to the task, but let's make the bar because it's a simple example. So the way you do it is you say attribute on, and you pass basically a bit mask specifying the attributes, and that's where this comes into place. Because, for example, what I would like to is to have like a reverse mode, which I think it's this one, which basically makes the background, like the color from, like, when you're talking about colors in a terminal, there is always a foreground and a background, always. So this reverse basically reverses that. And you have underlines and, you know, a bunch of stuff. So in theory, you like to say, oh, enable this and then disable this, right? So it basically, I imagine internally there is like like a bit mask, and when you do on, you change that bit on the mask with this one, and when you say off, it turns it back off. So even if there is other things enabled, you are only switching to the affected bits by this mask, right? Not very Swifty, of course, but we are working with a C interface right now, so that's what we need to do. But of course, this doesn't fly because it's not in the scope. Because as I said, you know, if you try to look for this here, ain't gonna work. Because if the CLang importer or something like that Swift uses, it cannot parse this stuff, right? It just says, oh, this macro is too complex, right? This one, I'm probably sure this one is there. Yeah, see, exactly, see, this one is there, and then you see the normal one, which is this one, so these two are there, but you don't see this one, and you don't see any of these. So, what's the solution? Rewrite it in Swift, which is kind of like a pain in the ass, let's be honest. What I'm gonna do is, I'm gonna do this one, and I'm gonna do it here. Where should I put this? Where can I put this here? Darwin and courses. Let's put it here. So that's what we need to do, right? So instead of a macro, let's make a function. And this is a mask. And you know, let's try to pretend it's still C. Now the question is, yeah. So we don't really know what this one is, but we can check this one, and this one is 32. But this is a uint, so this stuff is itself a uint 32. So I think we can use this in helpers, right? So it's a uint 32, and the shift it's a uint 32. So this is an internal way that ncurses has to deal with these masks, and we're gonna be returning, oops, a C integer type. So that's basically like the integer type in C. So it's the same way that in Swift you have integer and you don't have to specify the specific size. This C int, it's basically the same. Now here, of course, first of all, we need to make this a C int, and then this should work. So I mean, we don't need to do this, and like these parentheses are redundant, and then binary operator, yes. So in theory, that's because, yeah, because this guy, let me reverse this, it's a int32 for some reason, even though I'm pretty sure it should be a uint. Okay, so we have this now. We have this, but of course we don't have any of this stuff. I could go through all of them and just do it, but I want the reverse. So I can just do, for example, so I can here say, for example, or just do it more swiftly and say reverse it, and call this with a 1 and a 10, and that should do the bit mask shifting that I need, and we should be able to do this. Okay, so now if I run this, there you go, perfect. So we applied the reversed attribute, and the colors on my terminal, that's how like my profile is set up, it's black on the background and green on the foreground. So by applying the reverse, we just reversed this, which it feels like, you know, it has been highlighted. You know, we could play with the colors and all the stuff, but I think that for now this is enough, and we don't have to actually deal with the colors, you know, at least yet. Maybe later we actually want to start, you know, doing something with the colors, but for now I think that's good. Cool. One thing I want to do though is to draw the highlight across the entire bottom, so it feels like it's, you know, it's like a proper bar, like, you know, trying to do some fancy design, you know. Maybe some designers can learn from myself. So let's say this, and let's say width, and for the string itself we can just do string repeating, and we just put a space, and we do, that's the funny thing, like you can do width here, not here, sorry, yeah. So we start at 0, and how big we want the string, since every pixel in our screen it's basically a character, so we can just use the width of the screen to get as many characters as we need, right? So something we can do is say do, and now I can put this as the y, I guess we can call it, even though, you know, we remember that we're talking about lines and columns, not really floating point coordinates. And there you go. Easy, no? Fine, cool. So now we have like some sort of interface, right? Nothing super fancy, but we have some sort of interface. Cool. Now, what I would like to is to start working on the lines, to actually highlight and select the lines, right? So we have the basic blocks. And we can just do it. So let's see. So instead of this, let's have I move this into helpers with this, you know, so you know, we know where it comes from. So let's say that we have tasks, and for now let's just make it, you know, an array of strings. So we have a first task, oops, we have a second task, you know, stream the development of this. Okay, so we have a bunch of tasks. We have 3 tasks for now, and then this, instead of manually rendering this, we can do a for let's say y and task in tasks, and now we can move this here, and we can get rid of this. So what's the line? The line we want to draw is at y. Yeah, sorry, I forgot to enumerate it. And again, we need to convert stuff because, you know, integer types. The task is the string, so we can just say task here, and the, you know, indentation, let's just put it at here. Okay, so now we should have 3 tasks. Okay, so now let's highlight them. How do we highlight them? Well, I guess we need to have current, which starts at 0. And then here it should be as easy as to say if current equals y, then I just do this. I reverse it. I apply the attribute to reverse, so everything that it's done after this is going to be reversed. Of course, we need to clean it after every iteration. So if you applied this, no, because this defer is going to run too early, so I'm just going to do it here. And since it's a bit mask, applying this even when this is not true, so even if we didn't make the reverse, disabling the reverse doesn't do anything, you know, because it's just gonna set a bit to 0 that was already in 0, so who cares? So let's see what happens. Okay, so we have the first one selected. That's cool, right? It seems fine to me.